Welcome to this Executive Boardroom Pitch Masterclass. Today, we are cracking open our most critical client brief, the ultimate high-stakes strategy guide for Cambridge AS and A-Level Math 9709. I'm going to be acting as your Managing Director of Training for this explainer, and we are focusing on a project where most candidates completely drop the ball and lose incredibly easy marks. We're talking about definite integrals. Now, to really understand why students fail here, I want you to imagine we have two junior consultants on our team right now pitching this exact mathematical topic to the executive board. Let's call them Consultant Alex and Consultant Sam. Now, Consultant Alex, absolutely brilliant with the raw numbers. Alex has all the excellent data points, but completely fails on the executive summary delivery. The board is confused because the math has no context. On the other hand, we have Consultant Sam. Sam is a highly persuasive speaker, great narrative flow, but totally lacks the physical asset and case study backing to actually prove the point. The math is sloppy. Both of their proposals would fail the Cambridge examiner's audit. But after going through this session, your proposal won't. I'm going to show you exactly how to bridge that gap, eliminate those simple, unforced errors, and deliver a high-tariff response with the absolute clarity and authority of an elite executive consultant.
Here is our roadmap for today's briefing. We'll establish the core theoretical framework, move into technical methodology and execution, secure our method marks, and finally, audit the top 3 examiner traps. Section 1. The core theoretical framework. Okay, let's dive right into this foundational architecture. Our goal here isn't just to review equations, it's to execute a complete corporate mindset shift. We need you to stop thinking like a stressed-out student trying to survive a test and start operating exactly like a principal examiner. You are a consultant solving a high-stakes problem. When you look at the fundamental definition of definite integrals for this syllabus, notice what is intentionally missing. It doesn't just say, calculate the area under a curve. No way, that's too basic. Mastering definite integrals requires a massive, interconnected conceptual framework. Cambridge is actively searching for candidates who demonstrate mastery through precise definitions and causal relationships. It's about systematic analysis and evidence-based reasoning, pushing far beyond isolated equations. If you change a boundary limit, what is the exact causal relationship on the geometric outcome? Why does that happen? Because you see, this deep conceptual understanding is exactly what transfers effectively when you are faced with an unfamiliar, highly complex context on exam day. That's the core of the client brief. This right here is the ultimate examiner secret, pulled directly from official reports. And this is exactly where our two junior consultants, Alex and Sam, begin their structural strategy debate in the boardroom. Consultant Alex looks at this and says, let's just isolate the integration formulas. That's what gets the compliance points. But Sam pushes back, saying, no, the theoretical architecture of definite integrals doesn't exist in a vacuum. We have to persuade the board by showing how it connects to coordinate geometry and kinematics. And you know what? Sam is onto something crucial here. The principal examiner is explicitly telling us that referencing cross-topic connections achieves significantly higher marks. By strategically linking definite integrals to broader mathematical concepts across the syllabus, you signal to the examiner that you understand the entire corporate architecture of the subject, not just one isolated department. This cross-topic connection is your fundamental key to securing top-tier marks and proving you meet all the assessment objectives, the AO1, AO2, and AO3 compliance standards. So how do we build this into an actionable, repeatable strategy?
Well, because these concepts are so deeply interconnected, one of the absolute most elite techniques you can leverage is the visual story method. Instead of trying to aggressively rote memorize a disjointed list of rules, which honestly is a terrible strategy, you encode these definite integral concepts by anchoring your mathematical steps like a narrative sequence. It's a progression. First, we identify the boundaries, which physically causes our next step of setting up the integrand, which then naturally leads to evaluating the limits, and finally, generating our conclusion. You're telling a story with the data. This memory hack is an absolute game changer. It significantly reduces your cognitive load during a high-pressure exam scenario. Instead of panicking and struggling to remember what random formula comes next, you just follow the logic of the narrative. You focus entirely on execution.
Section 2. Technical Methodology and Execution.
Think of this next phase as your standardized operating procedure. As an executive consultant taking this exam, you don't just wing it, you follow a precise, repeatable workflow. What's really fascinating about this specific operational sequence is how frictionless your problem-solving becomes once it's fully memorized. Every single time you face a definite integral, you run this 5-step play. Step 1, you deconstruct the raw question to extract relevant data and identify key elements. Step 2, you select your analytical framework to apply the relevant principles. Step 3, and this is where consultant Alex usually shines, you execute that analysis with crystal clear mathematical notation and working. Step 4, you verify your results for reasonableness. Ask yourself, does a negative area make sense in this physical context? And finally, Step 5, you present your solution properly. Master this exact sequence, and you have literally built an automated machine for generating marks on your exam paper.
And speaking of that final step, presentation follows incredibly strict compliance conventions. You cannot afford to be sloppy here. This is where consultant Sam's approach usually falls apart in our boardroom scenario. Sam might have the right idea, but without proper headings, correct academic terminology, appropriate visual formats, and clear annotation, the examiner can't follow the logic. It's an instant fail on presentation. Data interpretation is absolutely critical for extracting evidence-based conclusions. You have to pull the data from the text, interpret the mathematical relationships, and draw your conclusions, all while communicating it in a standardized format that the examiner recognizes instantly. If they have to hunt for your final answer or guess what your annotations mean, you are losing easy marks.
Section 3. Securing the method marks.
Before we transition into the strategic art of securing marks for the analytical process itself, I want to hit pause for a quick mid-briefing action item. To ensure your academic portfolio remains highly competitive, take a second right now to subscribe to our channel Ace the Exams, at the handle @AceTheExams, and make sure you enable notifications for our weekly consulting insights. Okay, let's resume the briefing. Welcome to the Method Mark Strategy. Our consultants, Alex and Sam, recently encountered a critical flaw in their mock proposal. They got the final numerical answer wrong because of a tiny arithmetic slip, and they thought they scored a 0. But actually, scratch that. In Cambridge exams, marks are heavily awarded for the process itself. When tackling definite integrals, you are essentially adopting a deconstruct, solve, evaluate mindset. Think of it like the classic PEL writing matrix: point, evidence, evaluation, link, but translated for high-level math. You identify the given information, break it into logical steps, solve it systematically, and justify your steps. This methodology acts as a massive, bulletproof safety net for your score. You are earning exam points by proving to the examiner that your logical processing and methodological execution are flawless, totally independent of whether you dropped a negative sign at the very end.
This simple question right here is the dividing line between good candidates and top-tier executive candidates. Did you check your assumptions? Top scorers proactively demonstrate evaluative thinking. They actively question their initial assumptions, consider different mathematical perspectives, and justify their tactical decisions with solid evidence. Evaluating the quality of your evidence requires you to identify the limitations of your model. For instance, are your boundary limits correct for the specific quadrant you are in? Is the function actually continuous over the given interval? Always audit your own work before you submit the final proposal.
Section 4. Top 3 Examiner Traps.
Welcome to the climax of our masterclass, the live audit workshop. We are now going to run some rapid audience diagnostics based on the specific make-or-break traps identified directly from principal examiner reports. I want you to imagine a 60-second visual timer right now. We are under pressure, the clock is ticking, and we need to identify the highest value insights and the biggest risks. Let's start with trap number 1, a major structural pitfall that catches thousands of unprepared candidates completely off guard every single year.
Case Study 1 on our audit, using the wrong approach for the wrong context. This is the absolute classic trap in definite integrals. It happens when a candidate misinterprets the initial contextual scenario and just dives headfirst into the wrong calculation. If you don't take that crucial first step to deconstruct the question and extract the right data, you will invariably select the wrong analytical framework. You might execute pages of beautiful, flawless calculus, but if it's the wrong approach for the specific context of the question, like finding the volume of revolution when you were supposed to find a 2D area, you score 0. Your proposal is rejected. Always align your specific mathematical tool with the actual problem at hand.
Moving right along to the second trap in our risk assessment, and listen, this one is entirely 100% preventable.
Let's run a risk assessment on this text. Forgetting to check format and presentation conventions. Where does a sample answer lose its structural credibility? Right here. As we debated earlier, presentation is not an optional extra. It is a strict compliance convention. Candidates routinely forget to check their formatting. Losing marks over poor annotation, missing your brackets, dropping the dx at the end of your integral, or failing to present visual formats properly is an unforced error. It's like showing up to an executive board meeting in your pajamas. It costs you academic credibility, and infinitely more importantly, it costs you those easy, secure marks that you've technically already earned through your hard work. Don't leave money on the table.
And finally, we hit the absolute most crucial examiner trap. If you take away just one single thing from today's briefing, please make it this. Let's close the deal with this final comparison. Notice the stark contrast we have up here. On the left side, we have consultant Alex's initial draft, a generic, isolated equation floating completely without context. It's just numbers. On the right side, we have our polished, high-scoring final draft, context-specific analysis linked precisely to the scenario provided. And this brilliantly illustrates what examiners mean by comparative analysis and critical thinking. Comparative analysis in definite integrals requires supporting each step with evidence and drawing conclusions about relative importance. You must build a bridge between the raw math and the actual real-world scenario of the question. You cannot just leave a number like 14 at the bottom of the page. You have to state what that 14 represents in the exact context of the client brief. Here is your final Executive Framework Summary Checklist, delivered as a direct, high-value insight from the Principal Examiner reports. They are practically handing you the blueprint to pass. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Do not provide generic robotic answers. Always link every single analytical point, every boundary condition, and every final calculated result directly back to the given scenario. If the question is about calculating the area of a physical cross-section of a bridge, your final sentence needs to explicitly reflect that physical reality, not just a bare mathematical integer. That is how you close the deal.
So, how do we implement this corporate strategy today? Here are your immediate executive action items to ensure you absolutely maximize your exam score. First, if you haven't already, subscribe to our channel Ace the Exams at the handle @AceTheExams. Second, hit that bell and enable your notifications so you never miss our weekly consulting insights. And third, take this exact theoretical framework and apply it immediately to your past paper questions. Practice that deconstruct, solve, evaluate method until it becomes pure muscle memory. Also, jump into the comments right now and let me know your current level and your target subject so we can tailor our next briefs for you.
I'll leave you with this final provocative thought as we adjourn. When you sit down for your Cambridge Math 9709 paper, are you just blindly doing the math, crossing your fingers and hoping for the best? Or are you strategically auditing your answer, line by line, exactly like an elite Cambridge examiner? Shift your mindset, apply the executive framework we've laid out today, and go conquer that next pass paper. Thanks for joining me on this explainer, and keep leveling up.